All right, today we are diving into something huge, gravity. But maybe not in the way you think. We're going to look at it from a totally different angle. Forget about some mysterious force. What if it's all just geometry? Let's get into it.
So, let's kick things off with a little puzzle. Have you ever looked at a flight tracker for a long-haul flight, say from New York to Madrid? You'd think it would be a straight line across the Atlantic, right? But nope, it actually takes this big sweeping curve, way up north toward Greenland. What's up with that? Why take the scenic route?
Well, it all comes down to perspective. You see, when you look at a flat, 2D map, that straight line seems like the shortest way to go. But, and this is the key, our world isn't flat. It's a sphere. And on a curved surface like a globe, the actual shortest path is that big arc. It's called a great circle.
So get this, that curved flight path isn't about dodging bad weather or anything like that. It's not even about saving fuel. It is quite literally the most direct route you can take on a sphere. This whole thing, it's not an aviation problem, it's a geometry problem.
And that special curved path? It has a name. It's called a geodesic. And a geodesic is simply the straightest possible path you can travel in any kind of curved space. Think about it, an ant walking across an orange, a plane flying around the globe. They're both taking the most direct path. They're following a geodesic. This is where our brains have to do a little flip. That idea of a straight line we all have, well, that really only works in flat space. The second you introduce a curve, the rules of the game just change completely.
And this really breaks it down for us. You know, back in school, we all learned that the shortest distance between 2 points is a straight line. That's good old-fashioned flat space geometry. But in curved space, the kind that describes, our actual universe, the fastest, most efficient path is that curved line, the geodesic.
Okay, so we've got the whole geodesic thing down for a globe, right? The shortest path is a curve. Now I want you to hold on to that idea because we're about to take a pretty giant leap.
We're going to take this concept from our curved planet and apply it to the curved fabric of space-time itself. Yeah, this is where things get really wild. This is where Einstein comes in and completely rewrites the rules on gravity.
This right here, this is the revolutionary idea. Einstein's big insight was that objects in freefall aren't being pulled by some invisible force. No, they are simply following their straightest possible path, a geodesic, through a universe that is itself curved by mass and energy.
I mean, this is a huge shift in thinking. For hundreds of years, everyone thought of gravity as a force, like Newton described it, an invisible rope pulling things together. But Einstein's idea is so much more elegant. He's saying there is no pull. There's only the geometry of the universe, and everything is just following the contours, the path of least resistance.
So, how does this actually work? Well, for starters, you can throw out the idea of needing some mysterious force to explain gravity. It's not needed. And second, moving along a geodesic is the most natural, effortless thing an object can do. It's like a ball rolling downhill. So that feeling we have, that pull of gravity, it's really just us moving along these natural curves in space-time.
Okay, so this is all building up to one really crucial point. Seriously, if you take away just one thing today, let it be this next part.
Boom, there it is. Gravity isn't a force acting within space-time. Gravity is the shape of space-time. Mass and energy tell space-time how to bend, and in return, that curved space-time tells mass and energy how to move. It's this beautiful cosmic dance. And once you see it everywhere. The Earth isn't being tugged along by the sun. It's just following its geodesic through the giant curve in space-time created by the sun's massive presence. Same thing for satellites orbiting the Earth. Heck, even light, which has no mass, has to follow these paths. That's why we see light from distant stars literally bend as it passes by a galaxy or another big star. It's called gravitational lensing.
Look, this isn't just a cool science fact. This is a complete upgrade to our understanding of the universe. It's like we were running on an old, clunky operating system and Einstein gave us the new one. And it's not just theoretical. This is essential for making things like GPS work with pinpoint accuracy, and it's the foundation for how we understand black holes and the expansion of the entire cosmos. So, let's wrap this up with a nice, clean summary. What's a geodesic? It's simply the natural path that everything follows through curved spacetime. Objects aren't taking a detour, they are taking the universe's version of a straight line, the most direct and efficient route possible. And all this leaves us with a pretty mind-blowing question to chew on. If gravity, something we thought we understood for centuries, turned out to be just geometry, well, what else are we getting fundamentally wrong about the universe?
What other massive secrets are just hiding in plain sight, waiting for us to just look at them from a new angle? It's something to think about, isn't it? Thanks for diving in with me.